Hey everybody, this is Jacob Tucker here, and in today's video, I'm going to be walking through the fungible token standard and just a bunch of familiarization stuff that has to do with fungible tokens on the Flow blockchain. So that is going to be, setting up your account to receive tokens, sending tokens to someone else, burning them, and we're actually going to walk through it in Cadence code to try and help you better understand Cadence transactions, see why they are, or not, I guess better understand why they are set up to be super safe. And then also just kind of help you, when you're out there in the real world running transactions, maybe even better understand what the transaction's doing so you can better protect yourself from malicious scams. So I'm going to be working out of, my VS Code today. I'm going to just be walking through code. It's actually, the repo I'm walking through is the Flow Fungible Token V2 standard branch because Cadence 1.0 isn't out yet. So I'm going to be walking through this. I'll leave a link to this in the description in case anyone also wants to check it out. The fungible token standard, it has had a lot of updates, obviously, in this new Cadence 1.0 release. So maybe this video will also be very helpful for those of you who just want to get, familiarized with the new updates in the Cadence 1.0 version. Also want to point out that, Cadence 1.0 is obviously, underway right now. And if you want to, install the Cadence 1.0 CLI in order for all of this to compile correctly on your local computer, you can go to the Cadence migration guide. I'll also leave a link to that in the description. And you can scroll down until you see install Cadence 1.0 CLI, and you'll be able to copy and paste either this command or this command, depending on what system you're using, into your terminal. Okay, but obviously if you're watching this video after Cadence 1.0 has come out, then you'll probably just be able to visit the main install Flow CLI page. So with all that being said, let's just go ahead and walk through the fungible token standard. So there's I guess there's a lot of updates, but there's also not a lot of updates at the same time. Stuff like a total supply still exists. Having storage paths and public paths is still kind of similar. The main difference here, I would say, from the original standard is these functions right here: get contract views and resolve contract view. You'll notice that example token implements the fungible token interface, and the fungible token interface now implements view resolver, which requires, if we actually go and look at it, it requires get contract views and resolve contract view. So that is why all token contracts must implement these two now. And essentially, what they are is, as some of you may know, metadata on Flow, or more specifically in Cadence, is stored on chain as opposed to off chain. So, like for example, in other smart contract languages like Solidity on blockchains like Ethereum, metadata is stored off chain in things like IPFS, and then the IPFS URL is stored in the contract, right? And that's because of immense storage costs and gas costs on Ethereum. But in Cadence, storage costs are so cheap that metadata is actually stored on chain, which allows for better composability and all that kind of stuff. But regardless, these fungible token views are from the what's called metadata standard, and that is to allow people to better discover metadata on chain in Cadence. So you can see that in the get contract views function here, there's a bunch of different types that this contract is saying that it supports. So it supports a total supply, which we can actually see right here, right? It has a total supply. You can view data about, the token, like for example, a name, description, and thumbnail, which we'll see in a second. That's, I believe, the display. And then the view is more like technical things like a public path, storage path, ways to better discover that in a user's account. So we'll go over that too. And you can see in the resolve contract view, that's where we're actually, implementing these. So you can see in the in the display, we have like an example image, we have a name, symbol, description for our token, which is great. For vault data, this is all like the more technical stuff. So like the storage path is here, the receiver path is here. The receiver path is really like the public path for receiving tokens. We'll see that in a transaction. The metadata path is more for things like a balance or for reading metadata. Ultimately, they're actually the same thing, which is kind of confusing, and we'll see that in the transaction. But just to point that out. And then a total supply, and that returns a total supply. So this is, I think, the biggest difference actually between this new standard and the old standard is that the total supply is now no longer required, which I actually heavily dislike, but that is the new change. So total supply is no longer a requirement. As we can see, it's not in the fungible token interface, so you can actually opt in to say, okay, my token contract has a total supply, and if it does, you can implement that view right here. Everything else is actually quite similar. I would say the only other differences are obviously there's some different access modifiers, and on our withdraw function, right, we now have to specify that this has access of fungible token.withdraw because access is not dependent on types anymore. It's dependent on entitlements, and so we must have this withdraw entitlement here. And then in addition to that, there is this burn callback function. So a huge change to Cadence 1.0, and it actually is what causes this total supply mess, is that destroy functions are no longer supported in Cadence. Destroy functions were basically something where if a resource was destroyed, you can implement custom logic in that destroy function. The issue with that was twofold. One was people could put preconditions in destroy functions that basically never let users destroy. And B, you could have accidental things like integer overflow, underflow, stuff like that would make it panic. And so you would end up in a scenario where you could force a resource into a user's account, which was not good, and they couldn't destroy it. Of course, they could get rid of it, and I think that would have been ultimately a better route, but regardless, here we are. So destroy functions were removed, and so in order to handle that better, there's actually this burner contract that I actually have a whole video on this if you want to check it out. This burner contract allows you to implement a burnable resource interface and then pass it into this burn function. And so you can, if you want to destroy a resource, instead of just saying destroy resource, you can actually pass it into this burn function and it'll call a callback. And so we can see in this callback, it's going to say, okay, if we want to burn a vault, we're going to pass it into burner, and then we're going to call this callback function, which is going to reduce the total supply. So that way we can better track tokens. Again, obviously the huge downside to this is that users could, if they wanted to, not call the burner contract and just destroy tokens on their own. But if they do that, and then if they do that, the total supply will not be decremented, right? Yeah, that definitely stinks. But anyways, burn callback is here, and we'll see how that's useful in a moment. So that's the main changes with the fungible token contract. An example token contract that would implement the fungible token interface. And so with that being said, I want to dive into some code here. So let's say we wanted to set up our account to actually store tokens, right? So in this transaction, what's happening is, and I'll go over all of it, but just I'm going to try to do it in a way that makes sense. We're going to first check to see if the signer, which is the account that's being passed in, if the signer already holds a vault, or that specific vault at the intended storage path, then we're going to return, because the whole point of this transaction is we want to basically add a vault to our account and then allow certain things to be put to the public or to be published to the public. Like, for example, the ability to deposit tokens, read metadata of our vault. We want all that to be publicly available. So this transaction is going to set up our account to do that. So so this is going to say, okay, if we already have the vault, just return. We're not going to do anything on this transaction. Otherwise, create a vault and then store it in the user's storage. Okay, so signer.storage.save. All right. And just for those of you who are just watching this video to be better familiarized with Cadence, if you ever see in a transaction signer.storage.save or something.storage.save, just be mindful that something is being saved to your account. All right. And so after that, we're just saying, all right, signer.capabilities.storage.issue. I know that's a mouthful, but basically it's just saying we're going to issue a new capability that has this type. Now, example token.vault is actually a very non-scary. It's not a scary type in the sense that there's no entitlements on this, so you can't really do much with it. So it's totally fine that we're publishing this to the public. We do the same for receiver. And then that is that. Now, again, it's a bit confusing because we're publishing two public capabilities that both have the exact same entitlement and type to different public paths. This made sense in previous versions of Cadence because we needed, both the ability to deposit and read metadata and balance. Doesn't really make entirely sense anymore because we're kind of publishing the same thing twice. But I think we're sort of just going along with what was previously, so we still are publishing it twice. So yeah. Now, another thing I want to point out is this auth stuff up here. This is a bit confusing because it's so wordy, and it's probably scary to see all these things. All of these things that you're seeing here are entitlements. Now, these are basically things that we're saying are allowed, that this transaction can access on our account. So borrow value is saying, okay, we're going to allow this transaction to borrow a type from my account. That is dangerous, right? But that's going to be in most transactions that you're signing, because you're going to be manipulating some sort of data in your account. So this is necessary. But be mindful that when you see borrow value, that means that you're allowing the transaction to borrow a value from your account, which can do stuff, right? And so that's actually allowing us to do this, to check to see if we have a vault in our storage. Issue storage capability controller is allowing us to just issue a new capability. Publish capability is quite obviously allowing us to publish a capability to the public. This is also pretty scary, because if you ever allow the transaction to create a capability and then publish it to the public, just make sure that whatever type is, or whatever is being published, does not have that many, or does not have bad entitlements on it. In this case, this has nothing, so it's very easy, or it's not risky at all. And then save value allows you to store something in your account, and that's what allows this line. Now, if you wanted to reduce this, you could just reduce this to say, I believe it's borrow value and then capability. I think you can say this, and you wouldn't get any errors. Although, actually, let me try and do something here. Actually, you know what? I'm not getting any. What's it called? Errors, because even if I do this, it's not giving me errors. Let me try to relaunch this really quick and see if it'll give me some errors when I reload it. That's weird. It's not initiating the thing here, but I believe if we were to put borrow value here, and then also we might need save value and capability. It's just a shorter way of writing it. Capability will allow us to do everything with capabilities, but again, the more broad you are, the scarier it is, because you're allowing the transaction to access more things on your account, right? So anyways, we can just go back to, oh, okay, we'll leave it here for now. Okay, so then burn tokens, this is another thing I want to go over because of the burner that I was talking about earlier. So with burner, we're no longer destroying, we're no longer just saying, just like, for example, destroy self.burn vault. The reason for this is because, remember, it won't track the total supply correctly. So instead, what we should do is say, okay, you know what, we're going to go in, we're going to borrow our vault right here, and again, that's accessed by the borrow value. We're going to go in, borrow our vault, and then we're going to withdraw from that vault, right? And so this is the amount of this is the vault that we're going to burn, right? That we're intending to burn, and the amount is just specified by the transaction argument here. And then what's happening is in the execute, we're saying burner.burn and passing in that burn vault, right? And so it's going into this contract, going in here and calling the burn callback, which will correctly reduce the total supply, right? So that will track everything correctly. And you can see we actually have this post condition too that's saying, okay, we're going to check the total supply here, right? And then we're going to say in our post condition, make sure that the total supply was actually reduced by the amount, right? So to make sure that it actually went through. So again, this is just more of like a check, just to make sure the transaction worked. And if it errors out, it'll give us a nice little error message here saying, wait, that it didn't work. One thing I also want to point out for any of you curious Cadence developers out there is you'll notice now that in these transactions, we're accessing something called vault data, and we're getting our storage paths from vault data. The same was true in setup account. You can see right here, I just kind of skipped over it. The weird thing about this that I actually don't really like, and I don't know why I'm just like randomly inserting my opinion here, but just to note, in case it like provokes some sort of thought, is the weird thing about this is that implementing a metadata view is not a requirement, right? And so if a token, or if you were to run this transaction just using a different token, so like for example, instead of example token, we just put like I don't know, Jacob token or something like that. What if Jacob token doesn't actually support the fungible token vault data metadata view? What if I don't support that? Then what's going to happen is this is going to panic, and this transaction is not going to go through, even though it probably could work otherwise. And so that's what I don't really love about it. Instead, usually the storage path or the public path are known, in the sense that you could, kind of like if you're interacting with the token contract, on like your website or something, you would know the storage path because it's being set right here, and so you could look in that and actually get the storage path manually, not have to get this at all, and then just simply put the storage path here, and so that will sort of guarantee its success. Or you could just simply access it by vault storage path variable here. Although again, this isn't really a required. Actually, we can take a look. No, it's not. It's not a requirement, right? So yeah. So just a note there. I mean, this is totally fine in the sense that most token contracts are going to be expected to implement this metadata view, but just know that like this transaction might fail because implementing this view is not a requirement, right? And so this is an amazing way of doing it for a more generalized approach, but just again, note that this may fail if a contract does not implement that view, and you may have to replace the storage path directly. So that is setup account burn tokens, and then one more transfer tokens just in case. I know a lot of people run a transfer tokens transaction when they're transferring flow token to their friends, or they're transferring sloppy stakes or whatever token that they're transferring on flow. This is that transaction, and so again, there's a signer. That's you transferring to someone else. We have borrow value here. That will simply just allow you to borrow a type from your account. In this case, it's our vault. And so we're borrowing the vault, and then we're withdrawing the amount, which is the sent vault, which has a fungible token.vault type. This could also be just represented as a example token.vault if you want to be really clear on what you're withdrawing, right? As example token.vault. You can also do this. I actually kind of like this better just because you're sort of being very explicit about what exactly you have, right? And you're but yeah, I mean, it doesn't really make a difference, but just it doesn't make a difference at all. But if you want to be more explicit, you could represent it as that type. And then we are just borrowing a public capability from the recipient's account, getting their account like so, and then depositing to their collection. So that is what this transaction is doing. And again, we're getting the vault data here through the metadata view, but you could also just do this just as easily if you delete these, make your transaction a little less complex even, and replace the storage path directly, like something like this, example token vault. So yeah, I hope that was helpful. Just a quick, 18-minute video on just fungible token contract familiarization. Again, these are all the updates that are coming to the Cadence 1.0 fungible token standard. So I hope this helped all of you better understand it. And if you have any questions, as always, please join the Emerald City Discord in the description, or the Flow Discord as well, and I'll be happy to answer any questions you have. So thanks everyone, and have a great day or night. Bye.